I'm not seeing anything, so we can move on to the next one.
Okay.
And I'd like to thank the participants for firing quite a few questions at us. I'm looking to see if I am correct on study question number 4. Are the corrections the difference between the gyro and the grid azimuth and the convergence of the meridians?
Okay, the question, as I understand it now, is the meridian convergence the only correction? Well, not quite. And I think it requires a bit of a careful reading of the question. If you have a local coordinate system, very typically, well, it's not going to be a geodetic system. It will be something that's assumed within the mining area, meaning that it's not likely connected to a national coordinate system or whatever else. So typically it would be, say, the x-axis might be in the direction of the intended workings, the center might be at the middle of the shaft, and y would be at right angles to it. So that means that we don't have an easy way of taking a gyro azimuth, which is an astronomic azimuth, and relating it to this arbitrary coordinate system. So usually what they do is have a couple of reference points on the surface where the gyro is set up, and they have then a comparison between the azimuth by the gyro and the azimuth that's in the grid system. And it's usually then an angular correction, so that if you use the gyro anywhere else, you apply that angular amount, and that rotates it into the same direction as the local grid system. So you have really an orientation of the local system in with respect to the astronomic orientation that the gyro provides, or vice versa, depending on which way you look at it. Also, as you can anticipate and as you had suggested, as the working progresses away from the shaft, then we have to account also for the fact that there is a convergence of the meridians. Those seem to be the two most significant corrections that would have to be applied. Basically, what you could do if you wanted to investigate this would be to look at a publication that deals with taking astronomic azimuth and projecting it, or reducing it or correcting it down to a mapping plane. And as I remember, there's a couple of references in the geodetic positioning syllabus item, which will take from a surface measurement, which would be an astronomic azimuth, and reducing it down to a mapping plane. If you think of the mapping plane as usually specifically oriented, you can also look at a local coordinate system in much the same way. What are the particulars of how this local system would relate to the outside world, and come up with the corrections accordingly. And of course, part of this also has to be taken into the context of how well is this azimuth being done. If it's something for this superconducting supercollider as an example, everything is getting down to the individual arc seconds, as opposed to a typical mining, which would probably be more in the order of a number of seconds, even 10 or 15, depending on what they're trying to do and why they're trying to get the orientation. If it's a typical tunneling for other reasons, like say a railway tunnel, then you've got the example that's given by the two La Chapelle papers from the CPR tunnel in the Rockies. It would be a good indication of what sort of uncertainty magnitudes would be associated with that type of a process.
I expect so, and we also got a few questions, so we can move ahead and come back if we need to. The next one, if we state that we attempt to reduce all wind currents by shutting all ventilation shafts, will we get full marks? It seems we are expected to assume a lot of information that is not in the question. Therefore, memorizing a lot of information that is not applicable to everyday survey in the real world, we would attempt to reduce or have a pre-designed value that we must ensure we are within prior to the survey.
Okay, you will recall that that particular question was from 2009. If you were to encounter a similar question today, it would probably have more information in it. Also, I wouldn't want to be down below and have the ventilation system turned off. And I think let's put why this type of a question would have been there. And let's view it from the point of view of you as a surveyor. You're busy working away and somebody phones up and asks you in fairly general terms about shaft transfer. You can make some generalizations fairly easily, and this idea of the airspeed of being about 1 kilometer per second was mentioned in the chapter, that's a typical speed. Other typical uses, like usually the wire, if it's down to if it's going down to a depth of just several hundred meters as opposed to a couple of kilometers, then it probably has a diameter of 1.6 millimeters, and that makes a cross-sectional area of 2 square millimeters. If you're wanting to have some reasonable idea of what the magnitude is of an effect, then as long as when you're answering a question like this that may not have all the explicit values given, as long as you present a value that's reasonable. It would certainly be reasonable to say that the wire has a diameter of 1.6 millimeters as opposed to 5 millimeters or 3 millimeters. If you said 1 or 2, then that's probably still reasonable, although it may not be realistic to say a diameter of 1 millimeter. It's still a reasonable amount. Similarly, air current, if you said 2 meters per second or something like that, then as long as you're within a reasonable amount, then you would still have an acceptable answer. And the other thing is, as I mentioned in the study question 4, is also appreciating the context of the question. Study question 4 would be mining, which certainly would have a different level of precision associated with it than this super collider or other efforts for, say, doing accelerator layout. Although you may be using the same techniques and dealing with the same observables, you may have a different piece of equipment, a gyro theodolite rather than a gyro attachment, things like that.